Alright, so what we got here is we are looking at what we would call the electromagnetic spectrum. And so the electromagnetic spectrum is basically the whole focus of chapter 7 in the book. And so the first thing I kind of want to just draw your attention to is what the heck you're looking at and what all I actually am going to require you to know about this whole long spectrum of information. And so the first thing I want you to understand is I do not expect you to actually memorize every single one of these 10 to the third all the way to 10 to the negative 1 and 10 to negative 1 to 10 to negative 3.5. I don't expect you to memorize all of these values when it comes to these wavelengths and these frequencies. What I do expect you to know is the order in which we're talking about these things, or the general order in which we're looking at radio waves, microwaves, infrared, visible, ultraviolet, X-rays, and gamma rays, or vice versa, however way you want to kind of think about this. And so what I do expect you to know is the relationship between all of these. The only ranges I actually want you to be familiar with is just the wavelength of the visible range, or this right here, the 400 nanometers to the 750 nanometers. That's the only real range I want you to be familiar with, and that's because that's what's more important to us, is the visible range. Okay, so now that you know what you need to know and not to know, let's talking about what all these values and numbers and what this whole diagram is representing. So the electromagnetic spectrum is basically everything that exists around us, every single form of energy that exists at all periods of time. And so something that I've kind of mentioned in the past is chemistry is full of lies. But fortunately for me, I'm actually not the one telling you the lie this time. Your eyeballs and just the human brain is lying to you. And so out of this whole entire list of all of this amount of energy, and again, talking about wavelengths going from 10 to the third all the way down to 10 in the negative 11, all of this here exists. Out of this entire range of information, we see this tiny little sliver, which we refer to as the visible range. So out of everything that exists around us at all periods of time, we only see a very, very small fraction of that. And what I mean by that is radio waves. They exist at all periods of time. A great example of this is me recording this right now. It's going to the cloud, and the cloud is, again, nothing but a bunch of radio waves in which information is being transferred and stored and all of that. Same deal with microwaves. At some point, somewhere inside or in the world, probably in the US, someone's cooking some popcorn in a microwave. But again, whenever you cook something in a microwave, you don't see that. Nothing is really being emitted in our range of view. But again, your popcorn is still popping, so something is happening. And so whenever we kind of talk about all this information, gamma rays, X-rays, all these different forms of energy, they exist. We just can't really acknowledge it with our own personal eyeballs. And so when we kind of go through and look at this, the first thing you should kind of notice is when we go through and look at this range, radio waves have very, very, very long wavelengths. When you start kind of going down all the way to the other end, your gamma rays are going to have very, very tiny wavelengths. One thing that you should kind of notice, if you hopefully you've read this chapter already, is the fact that wavelength and frequency are completely an indirect relationship, or they're going to have an inverse relationship. And so as your wavelength gets bigger and bigger and bigger, your frequency is going to get smaller and smaller and smaller. And so one thing that's kind of exhibited in this picture is on the far left side, when we start talking about gamma rays, they have really small wavelengths, as you can kind of see up here. The peak to peak is what we're talking about when we talk about wavelengths. And going from this peak over to that peak is a very small gap. Whereas if you compare these wavelengths all the way over to radio waves, the distance from the top peak here all the way over to the distance of this peak right there is basically massive comparatively. And so when we talk about these, if you want to, again, you need to know the order of these, but if you want to memorize it in terms of wavelength, you're going to, again, memorize the fact that gamma rays have very, very, very small, like times 10 to the negative 11 wavelengths. And as you kind of start progressing, your wavelengths start getting greater, greater, and greater, massive. And again, 1,000 is not that big, but compared to 10 to the negative 11, it's pretty damn gigantic. On the other end, when we start talking about frequencies, If you have something that has really, really small wavelengths, it's going to have pretty massive frequency. And remember, frequency is just the number of cycles that this wave can kind of complete per a given period of time. And so if you notice here, because the wavelengths are very tiny, you can have a lot of these tiny wavelengths pass in 1 second. Compared to the wavelengths over here, you only have one giant massive wave that can probably complete it in the same amount of time. And so if you have very small wavelengths, you have very gigantic, again, frequencies. Going down in terms of frequencies, start off pretty big and you end up, again, relatively small. Again, 10,000, that's not small, but compared to 10 to the 20th, it is pretty small. And so we know this relationship here is going to always be an inverse relationship between your wavelength and your frequencies. Energy is also thrown in here, but we'll talk about energies in a later on video. And so when we kind of go through and start talking about all of these different types of energy, you're all familiar with gamma rays. You might just not know it. Gamma rays is basically if you're standing on the sun, that's what you're being bombarded by. Gamma rays are the bad type of radiation. Those are the radiations that can cause cancer and everything that's just, again, not good with life. And so the reason why they can cause cancer is because they have such tiny wavelengths, they're able to kind of sneak in between all of your skin cells and then go in between all of your other cells and then get into the DNA and actually start destroying DNA at a very microscopic level. And so again, gamma rays, those are the ones you want to stay away from. Whereas X-rays, again, it's still kind of high up there in the frequency level, but X-rays are not nearly as harmful to you as gamma rays are going to be. So X-rays are all familiar if you've ever been to the hospital and they throw you in front of that machine. That's the reason why the doctor puts on that huge lead vest and then just kind of says, all right, smile. And then they take the X-ray. And so X-rays wavelengths are small enough that they can fit in between all of your skin cells. They can, again, kind of go through some tissues and some organs. But as soon as they hit bone is too dense for these X-rays to pass through. So they kind of go out the other way, and that's why you can see bones with them. Ultraviolet radiation is, again, typically going to be associated with your night vision goggles. And so UV light is how some different types of animals actually kind of see things. And so UV light is, again, on the left side of the visible range, or as you can kind of tell here, ultraviolet is right next to the violet color in the visible range. And then on jump in visible range, again, that's what we see. That's just how we see color. And then on the other side, or on the red side of your visible light, you're going to be looking at infrared. Infrared energy is typically associated with heat. And so everybody gives off heat. Unless, again, you're not giving off heat, that's not a good thing. You're probably dead. And so infrared is going to be associated with heat. And so in these cases, if you have thermovision, or if you've seen any of the Predator movies, whenever he kind of goes and you see the blue and the red, that's infrared vision. He's just looking at heat difference or differences between the surroundings and whatever he's looking at. Microwaves, you all know what microwaves are. That's just how we cook popcorn and other situations along the case. Radio waves, we're all familiar with radio waves. The great thing about radio waves is because their wavelengths are so large and so long, they travel a huge distance. And we can all notice this. If we turn on a radio, we can probably find a radio station that is occurring in Austin and somehow reaching us all the way in San Antonio. The other thing you should kind of be familiar with when it comes to radio waves is if you're listening to the radio in the hill country, as soon as you're on the top of the hill, you can hear that radio station perfectly. But as soon as you kind of go down into a valley that is surrounded by mountains, then your radio station kind of conks out for a little while. And the reason for that is radio waves can travel through air a very good distance, but they cannot travel through earth or through mountains very well just because, again, they're not that great. They can't go through things like that. One last thing I kind of want to point out here is, as I mentioned before, you need to memorize the range when it comes to the visible spectrum. One thing you might have heard if you've ever looked at a rainbow is the term Roygbiv, or Roygbiv, Roygbiv. So Roygbiv is just the colors in the rainbow. And so here you're associating the red, orange, yellow, green, blue, indigo, and violet. If you memorize it that way, you just have to pay special attention to the fact you're memorizing it backwards. And by that I mean you're memorizing it going from your 750 nanometers all the way down to your 400 nanometers. So as long as you remember 400 is 750 and Roygbiv is backwards, then again it's can't help you in kind of memorizing the order. I think that's about it when it comes to electromagnetic spectrum. So please keep tuned to the rest of the videos because I'm going to go into a lot more detail with some of the other concepts.